It came with a bag of gerbil feed, and there was a gerbil spinning a wheel.
Welcome, everyone, to the Temporal 3 podcast. I'm happy to be joined today by my co host, Mr. Charles Aulner. Welcome, Charles.
Hello, thanks, Brian.
And Mr. Ed Heyden.
Hey, Brian, good to see you.
So, guys, this morning, I'd like to start out talking about the significance and the importance and how really important it is that our students remember the 70% rule in the NICET exam. Ed, how important is the 70% rule? I know this is something you are really passionate about and you like to bang on the table about.
Very true. You've seen my classes, haven't you?
Yes.
I'll be honest with you. It's a matter of pass or fail. The 70% rule is the line in the sand, pretty much, that you need to understand that you don't have to be 100% correct all the time. Just 70%.
Yep. That's a big difference between the real world and the NICET exam, and something that I know we like to emphasize to our students that, you only have to put in a 70% effort to pass the exam. You only have to be 70% correct. Obviously, in the real world, life safety, we got to be 100% correct. But in the NICET exam, 70% is good enough.
Good enough.
Charles, what are your thoughts on the 70% rule?
Game changer. This totally turns upside down the way we think about approaching an exam, and it's so important to be successful on the NICET test.
Have you found, Charles, that students in classes you've taught have had difficulty accepting 70%?
Yes, we're so accustomed in our world to do our best and go for 100%. The thought of disregarding that and focusing on that 70% required to pass is challenging to wrap your head around the first time you hear it.
Absolutely. And Ed, I'm sure you probably experienced similar type situations.
Well, I do have a little bit of a story about that. When I was on the road quite a bit with NTC, I'd come home and I'd have a honeydew list that my wife would give me of things that I needed to have done. And I tried to use the 70% rule with her. And I told her all I need to do is get 70% of these done. She said, well, that'd be a big improvement from your 30% you normally get done.
Hey, when a man's asked to do something, he does it. He doesn't need to be reminded every 6 months.
Yeah, that's right.
Well, 6 months, I've stretched it out to about 12 at this point now. If I, but yeah, in all reality, Brian, yes, the 70% rule when you're taking your NICET exam is key. As Charles said, game changing. When you're out installing fire alarm systems or life safety systems, you need to be 100% correct.
Yep.
Well,
I always
there
Go
is
ahead,
one
Charles.
other aspect I'd like to bring up about this. The concept of the 70% rule, getting 70% of the questions right, is easier to think about than it is to apply. Would you agree, Ed, that our students have had challenges with that?
Well, I do agree with that because we're a society, I think, that wants to do good in the respect of getting everything correct and answering everything, when the idea is to actually identify the ones that come the easiest for you without any research intensive study or code lookup. That's going to do just one thing, Chuck. It's going to waste your time on the exam.
Yep, absolutely. I think a lot of people struggle with that, and you're right. I see it in classes all the time where people will just linger on a question. In fact, in a class that we did yesterday, we had a student who could not let a question go,
Hmm.
who was frustrated by it and would not let it go. And I ultimately said, look, you got to remember 70%, and remember that basically any passing grade from NICET, 70, 80, 90, 100% is the same grade in the eyes of NICET. There is no advantage to you to work towards, or to focus on, I should say. You should work towards 100%, but focusing on 100% does not benefit you in the exam, because your 70% is the same as the guy who got 80 or 90 or 100. There's no advantage to you in the exam. And if anything, it increases your level of stress in the exam, and an exam that's already stressful enough.
Absolutely, and what all that equals to, from 70 to 100%? Well, that equals passing and certification is what that equals.
Bingo. Exactly. Now, I do recommend to our students to say to their boss, to their supervisor, that, hey, 70% is good enough for NICET. I should be able to put in a 70% effort in the field. But that doesn't always work. That
It
doesn't always fly.
doesn't work, right?
No, no, absolutely not. Well, guys, let's talk a little bit about code. FPA 72, 10.6.7, secondary power requirements. I won't ask you if secondary power is essential for fire alarm systems because we know it is essential for fire alarm systems, life safety systems. We got to have that redundancy. We got to have that supervision of the circuits. What are some secondary power options available for fire alarm technicians for fire alarm systems?
Batteries, of course,
Batteries?
that's one of them. Sealed
Is
lead
that probably
acid.
the most popular option?
I would say that's the ones you'll probably see in nearly 100% of your systems, nearly.
Yeah, pretty much.
And
Is
Ed, you used the term sealed lead acid. Brian, what do you have to say about that in terms of code?
NFPA got themselves in line with the IEEE, engineers working together, conspiring against the little guy, changed the term back in 2019 to VRLA, valve regulated lead acid, to bring themselves in line with IEEE description of batteries, because I guess sealed lead acid, SLA, wasn't a politically correct term anymore.
Well,
So yeah, VRLA.
I have to dumb it down sometimes, though, for the people that I'm dealing with. You understand? If I talk to them in that terminology, it gets very difficult for them to understand what I want.
Hey, I have difficulty understanding that.
Yeah. Listen, guys, to me, it's always going to be sealed lead acid batteries. They're always going to be sealed lead acid batteries. Now, what I talk about code, obviously, I'll say VRLA, but they're always
Yep.
SLAs. It's or not even SLA, just lead acid.
Agreed.
Agreed. So there is a second option for secondary power for the fire alarm system: generators. Have you guys ever worked on a fire alarm system that used a generator for secondary power?
Yes, I have.
Wow.
And there's different battery requirements based upon that also when using a generator, correct?
Absolutely, there are. Yes. 4-hour battery. So that's one that gets often overlooked
Yep.
is the 4-hour battery requirement. Just because you have a generator and the code states no signals shall be lost or delayed, you still got to have 4 hours of secondary power battery wise in case that generator fails to start.
Right.
The project you worked on with the generator, Ed, did it have one of those ones, with the wheels on it? You pull outside and you pull the cord a bunch of times and hope it starts. Is that the kind of generator they had?
It came with a bag of gerbil feed, and there was a gerbil spinning a wheel that was actually turning no, we actually had an electric start generator that electric started and then went to a gasoline motor, which actually made it. And consequently, the transfer switch was also critical based upon that, because it transfers over now to critical care circuits within another panel board. Yeah, and that panel board then takes over the initial panel board that's powering up the fire alarm system then. So we have a fire alarm system that's in panel board 1 in normal condition. When it goes to a generator, the generator transfer switch turns over, goes to another panel board, and that breakage now is controlling the fire alarm system.
Ed, I got to say, your electrical background is shining through with those terms panel board and transfer switch. You're showing your true colors.
Oh, thank you.
No wonder his wife married him.
That's right.
It wasn't for my looks, that's for sure.
I think we all definitely married above our station, so to speak.
She saw me with a code book and it was all over. It was love at first
That's
sight.
right. Hey, my first conversation with my wife was, see that over there? That's a manual fire alarm box, and that was it. She was
That's
all
all it
over me.
took. There we go.
Not well, guys. Secondary power requirements, and we've talked about a little bit about this previously. Have the requirements changed as far as capacity goes? I shouldn't say capacity. I'm sorry. Derating factor or safety margin, has that changed in recent code editions?
It has. It's
It
changed
used to be
from
20%. And
Mhm.
interestingly enough, old guys like me can remember when 20% was a best practice, not even a code requirement. And, so it's a situation where, yeah, generally best practice, we do 20%. They added it to the code. I believe it was 2010. And then they changed it to 25%. Why did NFPA feel the need to change that to 25%? Do they want everybody to buy bigger batteries, buy more lead and more acid?
Well, Charles, do you have an answer to that?
Uh, Not specifically, no. I mean, when we do the calculation for battery calcs, we base it on the typical load,
Mhm.
and it's possible that the devices could, in certain circumstances, draw more than that. So it's an assumption I would make that they said, hey, let's increase our battery size to make sure if that happens, we still have the adequate coverage that we need.
I would
I
agree with that.
I have actually investigated this topic as to why it went to 25%. And here's the reason why. NFPA is concerned about batteries. NFPA took a look at the battery market, and a lot of batteries now are made in offshore factories and stuff like that, and various chemistries. And there's there's the Life PO4 batteries and all these other new battery chemistries out there. And there's a concern about the quality of the manufacturing of batteries because, in the old days, there were a couple of US based manufacturers that made batteries, or, maybe a very limited number of people that made batteries. Now everybody makes batteries. FDA looked at this and said, we're concerned about this, so we're going to increase the safety margin on these batteries because this is life safety. We need these batteries to last. So now we're building in 25% as opposed to 20%.
I got to be honest with you. Out in the field, when we're doing inspections, I recently took over a group of occupancies from another dealer, and we just did our annual inspection for them. And out of 30 some odd occupancies, we had 10 of those occupancies fail batteries.
Hmm.
Yeah. The bat the system, of course, was showing normal because it had the series connection in 24 volts, and it was showing that. And you actually can measure the voltage on the batteries, but you looked at the date code of those batteries, and
Mm-hmm.
those date codes, and it's very specific. We're talking about the 3 to 5 year in service of those. I had one from 2004. How many years ago was that?
That
A
would be
lot.
It's a
22.
lot of years ago. Way too many. And here's the thing. I think we're touching on a topic of secondary power for these systems. I mean, without any type of inspection or visual inspection on these or periodic annual inspection, what the requirement would be, people could get lackadaisical based upon it until those batteries are actually needed to provide secondary power to the system when the primary power fails.
Yep, absolutely. Well, next thing I'd like to talk about, guys, is question from the field. We all love hearing from our students. We love hearing about their experience with our training and talking to them about questions in our NICET prep material. And today's question comes from our NICET fire alarm training. And the question is the maximum number of 14 gauge RHH conductors permitted in a half-inch EMT is. And the student was struggling with this because the correct answer to this question is 4. And we had to direct the student to look at the table a little bit closer because RHH, the particular type of conductor that we're talking about here, appears in that table twice. And we're talking about NFPA 70 Annex C, which is the conduit fill tables. And Annex C is really important in your NICET exam. You're going to see questions, probably at all levels, about conduit fill. And it's important to be able to navigate these tables and understand how these tables work. And the question that brought concern with the student was, well, wait a minute, I'm looking at the table. You say the answer for a half-inch conduit, half-inch EMT is 4, but I'm reading the answer as 6. And RHH appears in this table twice. There's straight up RHH. There's also an RHH with an asterisk. So our asterisks are important in NFPA 72. What do asterisks mean in NFPA 72, Charles?
Annex A.
Annex A. Yep. But there is no Annex A in NFPA 70. 70 works a little bit differently than the other codes.
Yes.
A completely different animal. So in this case, asterisk means that you go to the end of the table. So there's an RHH and then straight up RHH and an RHH with an asterisk. If we go to the RHH with an asterisk, go to the end of the table, this is an RHH without outer covering. RHH is I had to actually ask an electrician about this because I was unfamiliar with this cable, is a rubberized outdoor cable. And you can get it either as a straight up cable or a cable without an outer covering. The RHH without outer covering obviously is smaller diameter, allowing more to go into that conduit. So basically, the correct answer to this question is 4, because we're not asking about RHH without outer covering. We're talking about straight up RHH. So the answer is 4 versus 6. And this is one that we've seen students struggle with. But again, we structure our questions just to kind of trip people up, just like NICET does. We want them to be prepared. Ed, have you ever seen RHH used in a fire alarm system?
Not in the fire alarm system, no, but in medium to high voltage systems, yes. It's basically a rubber or thermoset type cable is what it is. And the outer covering basically is put on there by the manufacturer to improve moisture resistance, abrasion resistance, so on and so forth. As where the most common that you're going to see is the RHH without the outer covering, which would allow you more of a conduit fill than if it did have the insulation on the outside of it. Yes.
So, Charles, apparently NICET may ask you questions that do not have a basis in the real world because Ed said he's never seen RHH on a fire alarm system. I'd never heard of it on it. You probably never heard on it. So, is that something
No.
you do?
No, the NICET test is based on the code, and they don't expect you to just know the fire alarm part of the code. Especially with the National Electrical Code, it covers so much more than just fire alarm.
Very true.
And fire alarm wiring includes things that have lots of options. Sometimes in the real world, we have electricians pull our wire for us, and they may pull something other than fire alarm cable for certain circuits. Ed, have you seen that?
Yeah, mostly, Charles, if we have an electrical group that we've either hired or will come in afterwards to do the parts and smarts, so to speak, you'll see THW, THHN, and so on within a conduit environment. So yes, absolutely. But I've never seen. Well, I tell you, let me stand back. I have seen RHH, where we have actually seen. Uh, this guy made an extension cord for his fire alarm system. It was a multi-conductor RHH cable, and when we came in to do the inspection, he had it plugged into an outlet. So that's the only time, Charles, that I've actually
My
seen
gosh.
it that way.
Well,
Ed,
there's
you've
always
seen
interest.
some bizarre stuff out there, my friend.
Yep,
He,
you
he
remember what
knows some
state
things
I'm
because
in,
he's
correct?
seen. He knows some things because he's seen some things for sure.
I
Yeah.
have.
Well, guys, I want to thank you again for joining us for the Temporal 3 podcast. That concludes today's session. Thank you again for joining us, and I look forward to seeing you in the next one.
Thanks, Brian.
Thanks, Brian.
Thanks, guys.